Yo, yo, yo! What's up, everybody? Welcome to the latest and greatest video, Irrational and Irrational Numbers. This is part one. Let's get it. So, here we go. We have some key terms that we got to discuss. So, the first thing, and these are some pretty important ones, is we have square roots and a perfect square, cube roots, and a perfect cube. Now, the square root of a number is a value that when multiplied by itself gives you the number. So what we mean by that, and the square root symbol we use is this. So that is its symbol used for a square root. So if I were to ask you, what is the square root of 9? So what is the value of the number that when multiplied itself it gives me 9? So which number multiplied by itself is equal to 9? Well, the square root of 9 is 3. Because 3 times itself equals 9. Or in other words, if we went backwards, 3 to the second power equals 9. And another way to say this is 3 squared. So the square root is the opposite of 3 squared. Okay? So square roots and power 2 are opposite operations. They cancel each other out. So 3 squared is 9, so therefore the square root of 9 is 3. Okay, so whatever number times itself equals that number. So a perfect square are square roots that are integers. So the square root of 9 is a perfect square because our answer is 3. If I had the square root of 8, this is not a perfect square because I don't know what number times itself equals 8. 2 times 2 is 4, 3 times 3 is 9. Well, square root of 8's got to be somewhere in between 2 and 3 then. And it's going to be a decimal, so it's not a perfect square. Not a perfect square. Okay, and we will learn how to evaluate these, but as of right now, this is not a perfect square. I mean, not as of right now, this is just not a perfect square. Okay? Cube roots are the same thing as square roots, but the difference with a cube root is a cube root, it uses the square root symbol, but now it has a 3 on the outside. And a cube root is not just something a number times itself twice. It's a number multiplied by itself 3 times. So if I were to look for the cube root of 8, I'm looking at what number to the third power is equal to 8. So what number times itself 3 times? Well, 2 times itself 3 times is 8 because 2 times 2 times 2 does equal 8. So therefore the cube root of 8 is just 2. Because 2 to the third power, or also known as to the third power, is also known as cubed, is equal to 8. Okay, and we also can think of a 3-dimensional cube as well. Because we've always known that if we take the volume of something that's a 3-dimensional cube, if this was measured in inches, then the final volume would be inches cubed, because they're cubic inches. So then the cube root, if I knew that this volume of this cube was 8 cubic inches, then therefore each side would have to be 2 inches long. Because 2 times 2 times 2 is 8. Okay. A perfect cube is again same thing as a perfect square when we have an integer for our answer. A perfect cube is the same thing as a perfect square. So this is a perfect cube because 2 times 2 times 2 is 8. But if I asked for the cube root, let's say 7, that's going to be in between 1 and 2. This is not a perfect cube. We don't know what the cube root of 7 is. It would give us a decimal answer. Okay, and we're going to get a little bit further into this in just a second. So one thing that's also important is we're going to have to write down each decimal as a fraction and convert decimals to fractions, whether they're repeating decimals or terminating decimals. Now, in order to convert a terminating decimal, like part A here, to a fraction, we count how many values we have after the decimal point. So here's my decimal point, and I have 1, 2, 3 values after the decimal point. So that means I'm going to put all that over 1, 2, 3 zeros with a 1 in front of it. because we're always going to have 10, 100, 1,000, 10,000 in our denominator for decimals, because this is tenths, hundredths, thousandths. That's 825 thousandths. So because it's 0.825, 825 thousandths, I'm going to put thousands in my denominator. So now it looks like 825 thousandths. And then now from here, I would just have to simplify. Okay, so what I would do for simplifying this one, I know they have 25 in common. So I would divide by 25. Okay, and then from here, let's see, if I divide this by 25, 825 divided by 25, I get 3 minus 75 is 33. 33, and 25 divided by, I'm sorry, 1,000 divided by 25. That one's an easy one. It's just 40. So 825 thousandths is 33 over 40. Now, that's what we do if we have a terminating decimal. It's always going to go over 10, 100, 1,000. The amount of values we have after the decimal is how many zeros we're going to have after our 1. For repeating, it's similar, but instead of putting it over 10, 100, 1,000, we're going to put it over 9, 99, 999. So what I mean by that is because there are two numbers after there are two numbers that are repeating here. That's going to be 37 over 99. 37, 99. And then I would look to see if I can simplify. Okay. If I have 0.6 repeating, well, there's one number after my decimal that's repeating, so it's going to be over just a 9. So that's 6/9, which is equal to 1/3. I'm sorry, 2/3. Okay, try these three on your own. So try 4, 5, and 6. See how you do. And then unpause the video and check back in. So number 4, 12 hundredths. So if you know the same out loud, that helps you figure out what your denominator is. 12 hundredths means I have hundredths in my denominator. Also, because there's two numbers after the decimal, I have 1, 2 zeros. So it would be 12 over 100. And then I would have to simplify from here. I would divide by 4. That's the first one I see off the top of my head. That's 3 out of 25. First common factor. So there we go. Yep, 3/25. That's simplified. Done. So two numbers after my decimal, 57. It is a repeating, so instead of over 100, it'd be over 99. So 57 over 99. That I can actually divide by 3. So when I divide 57 by 3, I'm going to get 19 over 33 is the actual final answer. 1.4, I know my fraction is going to be 1 and something, and I know that 4 is going to be tenths because there's only one value after the decimal, so therefore that's 1 0. So it's going to be 4 tenths. That's 1 4/10, which is also 1 2/5. All right. Now finally, back to the square roots and cube roots. This is a list of all of the perfect square roots and cube roots up to 15. These are all perfect square roots up to 15. So the square root of 1, what number times itself equals 1, is 1. The number times itself that's equal to 4 is 2. Square root of 9, 3. And then it's going to count down. 4 times 4 is 16. 5 times 5 is 25. This list is going to be very, very, very valuable, especially when we start working with imperfect squares. So make sure you have this handy and you know exactly where it is, because it's going to be very nice to have this list. Now, real quick thing, when we have square roots of fractions, they look like they might be complicated, but they're really not. It's really just a square root of like 9 over 64 is really just a square root of 9 over the square root of 64. Because for fractions, a numerator times a numerator is going to give you your final numerator. denominator times the denominator will get you your final denominator. So the square root of 9 over 64 is just the square root of 9 over the square root of 64, which is 3/8. Square root of 9 is 3, square root of 64 is 8. If I take 3/8 and I multiply it by itself, I am going to get 9 over 64. So that's why the square root of 9 over 64 is just 3 over 8. Try this one on your own real quick. So square root of 25 over 100, square root of 25 is 5, square root of 10, 100 is 10. So the square root of 25 over 100 is 5/10, which does end up just being 1/2. Now some of you are saying, well, Mr. G, if I multiply 1/2 by itself, I get 1/4. That's not 25 over 100, and you're wrong. 1/4 is 25 over 100, because if I simplify this, this does become 1/4. So if I had simplified it first, I still would have gotten a 1/2 when I did my square root. Here's your list of perfect cube roots. So again, I would keep this handy. This will go all the way to 15 for you, because these are the ones that we may not memorize as easily, because not a lot of people know that 9 times 9 times 9 is 729, which is understandable. You've never been expected to know that, and that's okay. So that's why it's sometimes nice to have this list in handy. Cube root with fractions is the same situation. This would be the cube root of 8, the cube root of 100. So the cube root of 8, and actually let's make this let's draw it in for you guys here. Make this a 1,000. Make that a 1,000. Let's do that, okay? Because 100 is not a perfect cube. So let's make that a 1,000, just to make it a perfect cube for right now. Sorry guys, didn't catch that before. So cube root of 8 is 2, cube root of 1,000 is 10, 2 over 10 is 1. And if I had simplified this beforehand, I'm willing to bet I would have had 1 over 125 for 8 1,000ths. Cube root of 64 is 4. Cube root of 729 is 9. 4/9 would be the cube root of 64 over 729. Okay, keep this in handy. Make sure you know exactly where this list is, because we're going to need it. Things to remember. Okay, maybe draw your square root symbol and your cube root symbol. Okay, maybe you can write the square root of 10 is not a perfect square. We don't know what the square root of 10 is. All right, and then maybe we can also even write down repeating decimals. So if I had like 23 repeating, that's going to be over 99. Okay, so something like that, things that little couple notes to help you guys out. And then your independent practice, please give this a shot so that I can check it. And that's all I got for you guys. Hope this helped. And if you have any questions, please let me know. Gradius out.